Thanks, Jim. You're quite the character, and absolutely, if it wasn't for Jim, I probably would not be living in Hawaii. That's the straight up truth. So I'm here to tell you a story about GitHub's journey falling behind in dependencies and then catching back up. That in itself is pretty remarkable in my opinion, but the other things we learned along the way will hopefully encourage you even more to stay up to date on your dependencies. But I just want to start out by showing a fictitious study from a university that does not exist, where we asked 1,000 people who do not exist where the source of their code comes from when they get stuck. Obviously, copy and paste from Stack Overflow, very popular. Cargo culting, more or less copying code from your colleagues because it worked for them and maybe it'll work for you. Same thing, first result on Google, very popular. And down at the bottom, we have experience, and then practically nobody writes novel code for the most part. So for anyone who has written a non-trivial amount of software, have you never copied and pasted code? Raise your hand. Breaking news. Vulnerable dependencies are bad. But it's even worse. If you are an outdated version of a library, try getting help for that. You can't. If you're on unsupported software, try getting support. You can't. If you're trying to hire the best and brightest and you're on an antiquated stack, you can't. Another thing that comes up is for people who are on the most up-to-date versions, they come in with false assumptions about the safety of the code that they're using. And then if they have false assumptions about the code that they're using and they're on an old version of code, they're writing insecure code that for all they know is perfectly secure. Rails is a good framework for copying and pasting code. Copying and pasting code is seen as bad. It kind of indicates that you don't really know what you're doing all the time. It works. And oftentimes that leads to people who copy and paste code don't know what they're doing. They're bad developers. They're not as good as us. They don't understand security, blah, blah, blah. But what if, hear me out, the APIs were designed in a way such that it was hard to do the wrong thing, such that copy and pasting became easier to do the right thing. Now, I will get into an example of where Rails is not good at copying and pasting in this regard, but the idea of a secure by default strategy such that you opt out of security means that you don't really need static analysis. If you have a complex API with this crazy control flow, yes, you need to know where all the sinks and sources are. But if you have an API that just says opt out of security, that's a regular expression that pretty much anyone can write and automatically detect in their workflows. Rails isn't perfect. Rails is dying. Apparently it started in 2017. Same thing, Ruby is dying. Does Rails scale? This was the question. And apparently the answer is no, it doesn't. Rails is garbage, get rid of it. And of course, every year is the year of hating on Rails. But back to the good parts about Rails. I first saw Rails in 2006, and I didn't know anything about programming, really. I mean, I copied and pasted my way through college, but I finally started understanding these attack vectors, this OWASP top 10 thing that came out. I was like, oh, that's great. CSRF, that's bad. Every single web application in the world is vulnerable to this thing by default. The sleeping giant, I think, was one name they gave it. Turns out it might not have been as disastrous as we thought, but in 2006, I was scared. So Rails, I'm showing Ruby code, I'm very sorry, this might hurt somebody's eyes. But this is your base controller from which all your web controllers descend from. So how hard was it in 2006 to protect all of your Rails applications from CSRF? Done. Rails relies a lot on convention over configuration, and if you follow the conventions, one line of code would have protected you with state-of-the-art CSRF protection. At the time, I think OWASP CSRF guard was available, but I tried to use it, and we were on some weird, funky framework, and it didn't really work out. And the other advice would have about 7 pages of .NET or Java code with about 85 instructions on how and when to use it. I thought one line of code was way better. Another study SRI, sub-resource integrity, for anyone who's not familiar with it, it's a technology that allows you to specify the hashed value of the resources you're loading externally. So if your code is stored on a CDN, for example, especially a shared one, you kind of would want to know if that code got swapped out from underneath you, right? So if you're expecting to load jQuery and now you're loading, malicious Bitcoin mining, whatever, you kind of want to know about that. But literature on the topic is still kind of lacking, in my opinion. But in 2005, Rails kind of solved it. Josh, who is the author of this change, was also the person who implemented CSP. He is not a security engineer. He is one of my favorite people at GitHub. But he basically said, wait, we're using this asset packaging tool where it takes a whole bunch of disparate JavaScript files and compiles them down to like 2 or 3, minifies them, does some fancy like tree shaking to get rid of like unused code. It's really fancy. But the best part is it generates a series of sort of file name to integrity value mappings. So you add these 4 lines of code into your function that will generate a script tag for you, and you have site-wide SRI coverage out of the box, and nobody has to ever think about it ever again. So going a little bit back, I did not start with my history. Jim gave a little bit of intro, but I think my history actually directly plays into some of this and how I think. When I was working at UC Irvine, which is where I met my wife, we were using this unsupported custom framework built on top of struts that you could not Google the answer for, I tell you that. We became the maintainers de facto because we were the only people using that framework in the world that we knew of. It was around the same time that I saw Rails. Rails had this wonderful video by the creator that said, like, we'll create a blog live in under 10 minutes. And the way at which the agility where they could just modify the database, make changes, this, and this was great, because the other experience I had was, well, you compile these Java files locally on your machine, and then you copy them over through a Windows network share, and you hope that the libraries are there, but I don't really know what versions those libraries are. It's just a jar file. Kind of a different experience between the Rails experience. Then I worked for a company that is named after, that works with birds. This company also was famously on Rails. When I joined, they were on Rails 2.02. The reason I mention that is because 2.02 is very old. I joined in 2011. I believe 2.02 came out in like 2008. But even worse, not only were they an old version of Rails, but they had monkey patched it, which is the process of sort of at runtime changing the behavior of methods and functions. So if you really wanted to, you could make the string.reverse function just return a bunch of random garbage. But you had the ability to modify anything at runtime, and they did. And everyone did. This was like a Rails thing. This was really common. It was absolutely awful. Another thing they did was they vendored their dependencies. So the source of their dependencies were in the repo that controlled twitter.com. And then I think the most egregious thing that we ever did, including myself, was modify the source in those vendored library code. Not exactly your best software development practices. But it also made me realize that there was no way in heck we were ever going to catch up to modern Rails. And I think Twitter obviously realized that too, and they started to decompose things and write their own framework, and Scala famously. So the idea of making a contribution to Rails and having Twitter benefit from it was just like out of the question entirely. Not possible. And so in some cases, we ended up writing libraries. And that was great because it solved the problem, but still we weren't able to actually benefit from the ecosystem as much as we could have. So libraries can sometimes be like shortcuts. They're great, they get the job done, and then sometimes shortcuts don't work out so bad, and you might have actually like hurt yourself more than you helped yourself. Obviously, I can pick and choose when these situations apply because I'm up here. Then I worked for an Octocat. I came in and GitHub was behind on the Rails, and I thought, oh my goodness, I've seen this before. When are we moving to Scala? And they just sort of like looked at me funny, and I was just like, no, really, when are we moving to something else? And they said, no, we're Rails, we're Ruby forever. I said, all right, good luck. And I was wrong. I want to shout out to Eileen's presentation. This is a presentation at Ruby on Ice. I'm going to use a little bit of her content. I really suggest you watch this video. She's a great speaker, and she is my hero. She's a Rails core contributor. She started working for GitHub, and if it were not for her, I might have been right when, what I said before. So this is just a little bit of the history. This is Eileen's content again. In 2008, GitHub launches. In 2009, Rails 2.3 comes out. I guess I can point. But then what happens? GitHub forked Rails. So now we're on a custom version of Rails. And look what happened right after we forked it. Rails 3 came out. I'll get into why Rails 3 is important. But as you look at this timeline, we're starting the Rails 3 upgrade. Starting the Rails 3 upgrade here, and Rails 3.2 is coming out, and uh-oh. So that's when I joined Twitter, was in 2011. Where is Rails 2.02 on this timeline? Nowhere. Another thing that came out during this timeline was our project called SADB. This is the sort of static analysis automation framework that was really popular. This is its own talk in itself, and I'm glad to talk offline about that. But traveling through time and talking about why Rails 3 was important. Rails 3 was important because by default in Rails 2, you had to manually escape every single piece of data on the page. And that's really, really annoying. Also, it's really, really hard to not forget to do that every single time. Luckily, Rails had a very good static analysis tool that would often catch these things, but it's not perfect, and nothing ever can be. So Rails 3 moved to this sort of automatic escaping mode where you see before we had this call to H, and now it's gone. So I want to focus on this part specifically. Upgrade stalled are probably the two scariest words in the context of this presentation. If your whole posture is dependent on staying up to date and your upgrade gets stalled and new versions are coming out, you're quickly becoming antiquated. And again, we're still on the custom fork. And then January 2013 happened. This was a huge event for anyone that managed Rails applications, where it was basically like every week there was a new remote code execution or SQL injection or denial of service vulnerability. And I don't know if you've read it all, but that's the scary thing. Versions affected all, not affected none. I don't think that is actually as bad as it sounds. I'm pretty sure they exclude unsupported versions. But this one was bad enough, they actually backported some patches to unsupported versions, if I recall correctly. And even though like Twitter was a monolithic Rails app and GitHub was a monolithic Rails app, that doesn't mean we have one app and one repository and one Rails app. There's a bunch of small little ones running in our data center, may or may not be correctly segmented off. But it's, we had a lot of upgrades to do. But the best part was since Twitter was on an antiquated, custom, monkey-patched, vendor modified version, Twitter was not vulnerable. But unfortunately, GitHub was, and they had to do a lot of work to get these patches in immediately. Again, old custom fork of Rails meant that they were backporting patches themselves. And does anybody enjoy backporting patches to custom unsupported versions? No. So we'll travel a little more in the future. Rails 4.0 comes out in 2013. 2014, that little X-Men character here, Sentinel, that's GitHub's version of the static analysis pipeline that I had mentioned. But the most important thing on this slide is that Eileen joins right up here. The 3.0 being complete happened, this is me, I'm the Oreo shake right here. 3.0 being complete was huge. Like I walked in, they're like, oh, we just upgraded 3.0, and I was like, oh, that's great. How about 3.2? Yeah, we're working on it. But it actually went faster than I thought. It only took about 2 years. Then we started the Rails 4.0 upgrade when Rails 5.0 came out. So we're technically on a supported version, but it's, well, a supported version number. We're still on our custom fork, so it's not so great. But how did we do this upgrade? The most important thing we had was parallel CI builds. So we have a very comprehensive test suite. It is not perfect. No test suite ever is, but we have a lot of tests. I cannot run our entire test suite on my laptop. It would probably take 8 hours. Typically, it's just push and let CI deal with everything. And so what we started doing is we'd have these parallel builds. So while we were trying to upgrade to GitHub to Rails 4, we would run this optional test suite. And anyone who's familiar with GitHub is familiar with the various different test suites you can have on a pull request so that you can have a green status. We made this an optional build because the first time we ran it, 4,657 errors. Quite a lot. And by error, that means like the code does not run. Not the test failed, the code does not run. That means we had a lot of work cut out for ourselves. As we were making that suite green, we also realized that a lot of the big problems that we had was the customizations that we had were really blocking everything we did. So we had like a custom test framework, we had like a custom way that the databases were managed, and Eileen comes in and she's like, why is this so custom? Like the default stuff works just as well. And so she's sitting there ripping out all this janky code, and sooner enough, that suite became green, and then we went to 4.1, and then we went to 4.2, because 4 and 4.1 had some serious problems. Another important tool for this method was Canary Deploy. So Canary Deploy, the idea is that you deploy it to a small subset of servers, hopefully enough that if there were an egregious problem, it would present itself right away before you would go out to the rest of production. That's fine in theory. Sometimes it works out great, but you're really not going to know until you've deployed it to the entire world. So they would do sort of like off hours. We'll deploy it to production for like 5, 10, 15, 30 minutes, and just sort of gain more and more information as we went along. You can't just upgrade and then expect everything to work when you have millions of users. The other interesting thing that came out during this time is that while the security team was trying to make enhancements to the framework, we just couldn't. Like I got this change into Upstream, but we can't use it. So it kind of felt like, in a sense, we were wasting our time because we want to build these things, but if we can't use them, then what's the point? And our upgrade was still, kind of in an iffy state. And Rails 4.2, this is exactly what I'm talking about. Band-aids, backports, forward ports, deprecations. It was a nightmare. And this is where I think Eileen drew the line in the sand, and she said, if we keep backporting, we keep doing all these things, we'll never get off a fork. This was a pivotal moment in our history, because at that point, as a security team, we said, okay, we just got to stop for a little bit and then hope everything gets better. So back to the past again. Eileen joins, Rails 4.2 is in prod shortly after. More importantly, Rails 5.2 is in prod shortly after. And most importantly, we are no longer on a fork. We are on standard vanilla Rails. We have actually, one of the best parts of this, and actually I don't know why I didn't see this coming, is now that we can benefit from making all of our changes to Rails directly, Rails can actually benefit from all the changes that we made. So all the things that Eileen didn't rip out are now making themselves into Rails core. So it's a really good benefit and a really good symbiotic relationship there. So mission accomplished, right? Like we're on Rails master, like we're no longer custom code, we're vanilla, we're doing the right thing, like security's done. See ya. Wrong. Dependency management is very hard. This is a screenshot of our automated static analysis tool, and as you can see, it also runs regular expressions, which are incredibly effective. And for anyone not familiar with Rails or Ruby, the gem file is sort of your package manager file. The gem file lock is your lock file. So we monitor all changes to those files. Now, I will not say that we do a diff between each version and we review every single line individually. But if someone, for example, either adds or upgrades a very sketchy library, you best believe it's going to get some better eyes. And then this happened. I'm sorry, for people who maintain Rails, this was 2013 all over again. Because what happened? Versions affected all, not affected none. This was really bad. Arbitrary file read your etc password file, no problem. Any file on the computer, no problem. When people say bad things about Rails and these things come out, I kind of have to say, okay. The interesting thing here is this vulnerability was discovered by a GitHub employee, and the email that was announcing it also came from a GitHub employee. So you would think that I had some sort of inside knowledge on this vulnerability since being a GitHub employee. I'm also part of the Rails bug bounty team. This did not come in through the bug bounty team. But we had to be very careful. I didn't even know what the patch was until it came out. And I certainly did not know how to exploit it until somebody else figured it out. This was a little bit different from the 2013 edition where people were kind of sharing potential exploits and potential fixes so we could guarantee that the fixes worked and that production wouldn't come crashing down with all this extra code. Because this is also true, if you have a misconfigured Rails application, you can read sort of the encryption secret from a specific file. And if you're not using JSON to serialize your sessions in Rails, which is common now, and instead you're using like marshalling, which was the old way of doing things, this file read turns into RCE trivially. So what do we do? GitHub released a dependency management API such that you can see all the things your project depends on, and you will get notified if we know of a CVE for any of those projects. So we built a chat ops. GitHub very much runs on chat ops. Everything we do happens in a chat room. We do not use a third-party UI if we can avoid it. All the conversation, all the action, we deploy from a chat room, we run a test from a chat room, we say hi from a chat room, and we also look for vulnerable Rails packages in a chat room. This is a public API. This is not some Rails, some GitHub inside secret sauce. This was built with the public API. So if you want to build something like this, it is very much possible. So after the Rails Apocalypse 2019 edition, we obviously had some work to do. Like I said, we don't have one repo. We had lots of them. So from repos to and is really impressive. I don't want to give the numbers because obviously it may look good to some, it may look bad, but it doesn't really add value here. The thing is, we built this system to sort of automatically detect and then manage everything. It would open an issue for every repository that was affected, and it would automatically add this to this GitHub project board. Again, none of this is secret sauce. Anybody can do this. And we could actually watch the issues get triaged or marked as invalid. And while it's not fun to have to go through a fire drill, it was definitely reassuring to watch that thing in real-time update and watch everything move over to the right, indicating that they had upgraded and that we were in a much better position. So now that we're on the current version of Rails and we have a strategy for managing our dependencies and making sure we stay up to date, we can start making enhancements to the framework itself. Now this in itself is not an enhancement to the framework, but it's something I encourage everyone to do. Banning unsafe APIs has been very popular for a very long time. I don't know why it's not more popular. The raw function in Rails basically says, I don't care what this data is, give me the unescaped version. And the number of times you actually want to do that is exactly 0. So we banned this API in favor of the more complex APIs for building complex HTML outside of a template, for example. So what we did was we first disabled it in test. So if you call this message during our test suite or your development suite, it would raise an error. We can't do this in production because obviously we don't have 100% test coverage. But once we had removed it from dev and test, we had really good confidence that nobody was introducing new ones. Also, our static analysis tool would have also caught this. CSP. Anyone knows me knows I don't shut up about CSP, and I believe Leaf has to take a drink because I said it once. Not very many frameworks have built-in CSP support, but Rails has a DSL for managing your policy. It has nonce capabilities. It has dynamic overrides, so you don't want to open up a specific source to all of your pages, but like a very specific part of your app. It's really easy to have a very tightly defined CSP using this API. This one is a bit controversial because this actually isn't a solution. This is only a partial solution. But Dangling Markup is a bit of a problem. If anyone is familiar with, I have no idea how to pronounce this. El Kamtuf, I believe is his name. Okay, so he wrote a blog post a long time ago called Postcards from the Post-XSS World. Like, once we fixed XSS, what do we focus on next? Well, Dangling Markup was one of them. Now, what am I talking about Dangling Markup? Well, I'll start with the fix before I get into the problem. We add this now before every form tag in our application, and I will explain each one of those and why they work for now. But the important thing is it's automatically done by the framework, not the developers. So if an attacker is able to, so again, we're post-XSS. We know you can inject a script tag and do stuff, but we're past that. So what does an attacker do? They inject a form, the form that doesn't have the closing tag, the form that opens a select option, the form that creates an option and then throws a plain text tag in there. I'll show you why this is bad, but if you look at our protection here, we actually close off the option, we close off the form, and then our form down there is still in good shape. But because of that plain text tag, the attacker actually gets everything after the body. The plaintext tag, unfortunately, does not have a closing tag. It will keep eating everything until you get to the end of the page. Mike West, please help us. Going back to the Rails convention over configuration, I talked about how CSRF protection was a one-line change. But how can CSRF protection get better? So we know that we have to protect these verbs. Now we know browsers actually don't issue deletes or patches or puts, but Rails does treat them separately. This is essentially gets versus posts here. The posts are highlighted. Now going back to our dangling markup form injection type stuff, what if I was just to insert a form tag in that top example? The browser will ignore the nested form tag because nested forms are kind of, I think they're sort of undefined. So now the attacker has changed and they're going to send their authenticity token to attacker. Same thing down here. The user just meant to, log out, but instead they're going to change their password. Probably not what they wanted to do. And when you have a static CSRF token, at least per page, one token rules them all. So instead we have per form CSRF tokens. You'll just have to trust me that when I say value equals A and value equals B, that these CSRF tokens are indeed different. The CSRF token is based off of the action and the verb. And because we include the ID of the thing in the action itself, every single action has a custom CSRF token. So if you were to exfiltrate one, it would have limited use. Perfect. So to prove to you that this is useful, Facebook had a bug. And it would have saved them $7.5 thousand if they would have implemented Perform CSRF tokens. This was a fun one. It was called client-side CSRF. Basically what happened was there was some front-end code that was supposed to post to some other form, but through some fancy JavaScript, they actually changed the action. So now the form was going to be posting to somewhere else. The form is going to be posting to their GraphQL interface instead of their analytics endpoint or something. And if you have an authenticated request to GraphQL, you've got full access to the graph that user has, and that's very bad. Perform CSRF tokens thwarts this kind of attack. Now, I said Rails is not perfect for copying and pasting. This is one of my favorite websites in the world, railsqli.org. Everything good I've said about Rails can probably be taken down by just one look at this website. The ORM in Rails has issues. The ORM in Rails has issues if you use it incorrectly to some, or it just has issues to some. I think it just has issues. And I want to give an example of a Rails SQL injection that happened to GitHub. It was very fun. It was Christmas Day where I was, and I received this report, and it was pretty much legitimate. And it came down to someone was calling the order function on the ORM, so order by ID, descending, whatever. And they just sort of put in the user parameter right there with no sanitization, whatever. Now, Rails should know that if you don't say a column name and a direction, it should be no thank you, but it just accepted the raw string. And there is actually a valid use case for why this happens. So we thought about making more robust SQL injection protection. And this is more or less the exact bug that I was talking about. To the order function, you plop in a user-controlled param, and it's bad. So instead, what we're doing is we're now forcing people to use either the other method that accepts the column name and the direction, or you have to explicitly say I am using some raw SQL right here. I know exactly what I'm doing, and linters can catch that pretty easily. Oh, this was really popular, except one person thumbs downed it. I didn't understand that. All right, so here I'm just going to say things, and you can boo at me if you'd like. People will copy and paste code. Let's try to make it safer to do so. We cannot make it completely safe, but we can actually try. We added Rails protection for all Rails application users with 1 to 3 lines of code. We should stop shaming people for what they don't know and stop shaming people who promote us and them. And we should stop supporting unsupported code. Lastly, design security trade-offs as an opt-out decisions and monitor the exceptions and start contributing to open source. Copy and paste away.
So one of the things you said is we don't want us and them. A big debate that triggered from the conference is Do you think security engineers should know how to code? Because whenever we say stuff like, hey, security engineers, you really should learn how to code, a lot of security engineers who don't code get really offended, and it turns into a lot of us and them. So what do you think on this topic?
I think we all have various experience. I think we all bring something to the table. There's going to be an imbalance from here and there, but like I don't necessarily, I like to code. It makes my job a lot easier, but I know plenty of people who can do their job without coding. I would encourage people to learn how to code, but I wouldn't say if you can't code, you're not a security engineer. I also don't think that we should have like titles of security engineer versus engineer. I think we're all just engineers. That's my take.